Which is faster in Python, x5 or math.sqrt x? I've been wondering this for some time. As the titles say, which is faster, the actual function or simply raising to the half power. Update. This is not a matter of premature optimization. This is simply a question of how the underlying code actually works. What is the theory of how Python code works? I sent Guido van Rossum an email cause I really wanted to know the differences in these methods. My email. There are at least 3 ways to do a square root in Python: math.sqrt, the operator, and pow(x,5). I'm just curious as to the differences in the implementation of each of these. When it comes to efficiency, which is better? His response. Pow and are equivalent. Math.sqrt doesn't work for complex numbers, and links to the sqrt function. As to which one is faster, I have no idea.
Math.sqrt x is significantly faster than x0.5. 10 loops, best of 3, 156 milliseconds per loop. Ten loops, best of 3, 91.1 milliseconds per loop. Using Python 3.6.9 Notebook.
First rule of optimization: don't do it. Second rule: don't do it yet. Here's some timings. Python 2.5.2 Windows. This test shows that x.5 is slightly faster than sqrt(x). For the Python 3.0, the result is the opposite. Math.sqrt(x) is always faster than x.5 on another machine, Ubuntu, Python 2.6 and 3.1.
In these micro benchmarks, math.sqrt will be slower because of the slight time it takes to look up the sqrt in the math namespace. You can improve it slightly with. Even then though, running a few variations through timeeat show a slight 4 to 5% performance advantage for x.5. Interestingly, doing sped it up even more, to within 1% difference in speed, with very little statistical significance. I will repeat Kibbe, and say that this is probably a premature optimization.
How many square roots are you really performing? Are you trying to write some 3D graphics engine in Python? If not, then why go with code which is cryptic over code that is easy to read? The time differences would be less than anybody could notice in just about any application I could foresee. I really don't mean to put down your question, but it seems that you're going a little too far with premature optimization.
If you want to see more, please consider subscribing.